So the periodicity period 3, this time it's the reactions with oxygen. So all of the solid elements from sodium to sulfur are oxidized as they react with oxygen. The general equation for these are the element plus oxygen to form an oxide. The oxidation states of the oxides usually match the group number of the element. However, sulfur is an exception to this. It forms sulfur dioxide, where the sulfur has an oxidation state of +4. The reason it doesn't form SO3, which has the +6 charge, sulfur's in group 6, is because a high temperature and catalyst would be required for this product to be formed. So to work out the equations for the oxides, I'm going to use the example for sodium. So the first thing you do is you look at the oxidation state of the period 3 atom. So sodium's in group 1, so it's got a +1 oxidation state. Oxygen has a -2 oxidation state. So to neutralize the oxide, we want it to be a stable neutral compound. We'll need 2 sodiums because they have +1 charges each. +2 -2 makes 0. So now you know the product, Na2O, we can just work backwards to derive the rest of the equation. So we know we need 2 sodiums and we're going to need half of an oxygen, because don't forget oxygen is diatomic. So now put everything together and we've got our equation, 2Na plus a half oxygen to form sodium oxide. When sodium is burned, it's a vigorous reaction and we'll see a yellow flame of the oxide. When any of the solids from magnesium to phosphorus are burned, the reactions are very exothermic. What we see as an observation is a very bright white light and white smoke of the oxides. Finally, when sulfur burns, it does so steadily, so it's got the least vigor of all of the elements of period 3. The observation for this is a blue flame, and as you can see I've cleverly coloured the background in blue. A special note though for sulfur dioxide is it's a pungent, so it's got a very strong smell, but colourless gas, so you won't actually see any of the sulfur dioxide. And that's it for the reactions with oxygen of the period 3 elements.